We want to do some special factoring here, starting with factoring the difference of two squares. Now you may recall that we had some special products that ended up as the difference of two squares, and if I write those formulas backwards from the way I did with multiplication, I would have this: a squared minus b squared is always equal to a plus b times a minus b. Remember, this product, a plus b times a minus b, always ended up with the difference of two squares. Well, if I write it in this direction, then I'm doing factoring. So if I notice something has this form, then I know that it will factor into this form right here. And I see that x squared minus 9 is the same as x squared minus 3 squared. So it's going to factor into x plus 3 times x minus 3. Likewise, 9a squared minus 16b squared is the difference of two squares. The first square is the quantity 3a squared, so I'll have 3a and 3a, and the last term is the perfect square 4b quantity squared, so plus 4b and minus 4b. So 3a plus 4b times 3a minus 4b will always result in 9a squared minus 16b squared, the difference of two squares. Let's look at some trinomials now that may or may not be perfect squares or squares of binomials. Our first one, we have a squared minus 10a plus 25. And I'm going to say this may look like a squared plus 2ab plus b squared. If it does in fact have this form, and there's a clue that it does because the first term is a perfect square and the last term is a perfect square. If it does in fact have this form, then it is the square of just a plus b. So we can try to factor it that way and just see, is this a plus 5 quantity squared? That is a plus 5 times a plus 5. Well, if I square this, I get a squared, that's that, 5 squared, which is 25. The product of the two terms is 5a multiplied by 2 is 10a. So let me get this sign right. A minus 5 quantity squared. A times minus 5 is minus 5a doubled is minus 10a. So this trinomial right here does in fact factor into a minus 5 quantity squared. One more problem. How about 4a squared plus 12a plus 9? Let's see if it is. If it is, it's the perfect square 2a plus 3 quantity squared. So square the first term, get 4a squared. Square the last term, get 9. The product of the two terms is 6a. Doubled is 12a. So yes, this is in fact the factorization of this polynomial. And by writing 2a plus 3 quantity squared, I mean 2a plus 3 times 2a plus 3.